Routing Information Protocol in Palo Alto Firewalls.
Routing Information Protocol is a distance vector dynamic routing protocol. Now, RIP is an open standard routing protocol, and the function of any routing protocol, whether that being RIP, EIGRP, OSPF, ISAs, BGP, and others, the general function is to exchange network prefixes and then route packets for those networks. Now, what do I mean by this? Let's say I have a router here and another one here, and they're somehow connected. This is, let's say, A and this is B, and I have a couple of networks behind A and a couple of networks behind B. Now, the function of any routing protocol is to exchange network prefixes. Now, A has 3 networks, it will exchange to B, saying that if you want to go to any one of these networks, forward the traffic or packets to me, and B would do the same by sending these 3 networks to A, saying that if you want to go to any one of these networks, forward traffic to me. So that is the general function of any of the routing protocols, which where in static routing we had to do this thing manually. Now there are 2 versions of RIP version 1 and RIP version 2. Now in old days we used to use RIP version 1, however nowadays we don't use this anymore because there are some drawbacks to it, RIP version 1, because RIP version 1 is a classful routing protocol, meaning that it does not support VLSM, variable length subnet mask is not supported here. What do I mean by this? Let's say I have 3 routers here, and they're, let's say, A, B, and C, and they're connected like this. And there is a network behind A and there is a network behind C. So the network that I would have the major would be 192.168.1.0 slash, let's say, 27. So the major network is from class C. However, what I've done is I've borrowed 3 bits here, which means that I've done subnetting here. So the next subnet, what I would do is I would, let's say, allocate here 1.32, let's say 27. Now, if I use RIP version 1 in this type of a situation, what happens is that router A would forward this network as /24 as class C, default class C network to B, and router C would do the same by sending this network to B as /24 as well. So router B would get confused that who actually holds this network 1.0, 192.168.1.0 is being sent by this guy, and 192.168 is being sent also by C to B. So if B has traffic to be sent to maybe this subnet or this subnetted network, so B would actually get confused. What should he do? Where should the traffic actually be forwarded? So RIP version 2 is a classless routing protocol, meaning that it does support VLSM, variable length subnet mask is supported. So now if A sends this network to B, it would send it as of /27, and C would also do the same thing by sending this network to B as /27. And RIP version 1 does not support authentication, neither the clear text nor the MD5, message digest 5, none is supported here. However, RIP version 2 does support authentication. So before exchanging network prefixes between A and B, they would actually authenticate each other by maybe using a pre-shared key or using message digest, clear text version and the encrypted version. So they will authenticate each other. Then after once authenticated, they will exchange prefixes with each other and then route packets for those networks. Now, another drawback to RIP version 1 was that it was sending the updates as of broadcast. So it was sending it to everyone. Whoever, maybe out of this interface, it was sending it out of this interface. Maybe there was a device here that does not need it to receive updates or RIP updates. So it still was sending to everyone. So that was another drawback. Now RIP version 2 uses multicast, where the reserved address is 224.0.0.9, where now if router A wants to send updates to its neighbor devices, what happens is that it would actually send it to this group address. Whoever is using this group address would actually receive and accept the updates that are sent by, let's say, A, maybe in this case, or maybe B or C. The next thing that you need to know is administrative distance. Administrative distance is actually the believability of the information. So the default admin distance value of RIP is 120. So the lower the admin distance value, the more preferred the information. And the range is from 0 to 255 in Cisco. In Palo Alto, it's from 10 to 240. So every vendor has its own admin distance value for every routing protocol. Now every routing protocol has its own admin distance value. Like EIGRP has 90, RIP has 120, OSPF has 110, ISIS has 115, and BGP for external is 20. For iBGP it's 200. For static it's 1. For directly connected it's 0. So every routing protocol has its own admin distance value. Now what this actually means is that if I have a router here and a router here and a router here, and they're connected like this, and I have a network behind them, which is maybe, let's say, network X, and I'm, let's say, using RIP here, and I'm using, let's say, OSPF here. So this is, let's say, router 1, this is 2, and this is 3. So this is RIP, and let's say this is OSPF. Now router 2 and router 3 both would send network X to router 1. Now router 1 would have to decide whether it should, when it has traffic to be sent to X, which path should it select? Shall it forward traffic via RIP to router 2, or shall it send to 3 via OSPF as a routing protocol? So the lower the admin distance value of the routing protocol, router A would select that path or that routing protocol and send its packets and accept that update and put it in its routing table and then forward packet. So in this case, RIP has an admin distance of 120 and OSPF has 110. So router 1 would select this routing protocol and this path to reach network X. So if you are having two routing protocols, then admin distance value comes into play. If you have the same routing protocol, then another thing is there which is called metric. Now every routing protocol has its own metric. In case of RIP, it is actually using hop count or handoff point. So let's say I have a router here, one here, and one here, and they're, let's say, connected like this. And let's say I have a network that is here, which is network X. Now in this environment, if let's say I'm using only RIP as a routing protocol, so this router would learn network X from two different sources, two different ways to reach network X. So now RIP would say, if this guy wants to go to network X, if it goes via this path, it would say I have to go 1 hop, 2 hop, and 3 hops away, 3 handoff points away. If I go via this path, it's 1 and 2 hops away. So this guy would prefer this path and forward packets to network X. So that is how hop count works in RIP, and that's how decision making is done in RIP as a routing protocol. Now we have something called count to infinity. An update in RIP routing protocol can go max up to 16 hops. So what that means is that if this router has something network X here, now this router 1 would forward it to its neighbor, which would go 1 hop. That neighbor would send it to another neighbor, 2 hops. That neighbor would send to another one. So the max it can go is 16 hops. It would not exceed that. So if it exceeds, then it's called count to infinity. The max an update in RIP routing protocol can go is up to 16 hops. Now RIP has timers, and the interval time is 30 seconds, meaning that every 30 seconds, if this guy has an update, let's say this router 1 has an update, it would every 30 seconds send its updates to its neighbor saying that if you want to go to this network, come to me. If you want to go to this network, come to me. If you want to go to this network, come to me. Every 30 seconds it's being done. These updates are being sent, whatever the number of updates are there, 1, 2, 5, 10, whatever. Now, if this guy does not receive anything in 180 seconds, that network X, which was sent by 1 to this, let's say 2, now this router would say that is an invalid network now. Now it would wait 180 seconds, which is the hold down timer. It would wait 180 seconds waiting that maybe there is another router, maybe another router would come and tell me about that network X, maybe through this way. If it still does not receive anything in 240 seconds, this router would remove that network X from its routing table and flush it. That is the default flush timer. We can modify these timers as well. They are modifiable and changeable. So that is the general definition to RIP routing protocol. Now let's go ahead and configure it.